Hello, algebra students. Mr. Lawrence here, and I just realized I feel like a DJ because so many of you are sending me requests and I'm playing your favorite hits. Today's hit goes out to Rebecca Kowalski. She wants to know about the quadratic formula and axis of symmetry. And so I'm going to use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, I'm going to use the quadratic formula to help me find out where the parabola is going to cross the x-axis. That's the whole function of the quadratic formula. So I'm going to start by identifying A, B, C. It'll be easy as 1, negative 5, 6. And then I'm going to use the discriminant, the b squared minus 4ac part of the quadratic formula. If this comes out to be positive, I'm going to continue to use the whole quadratic formula. If it ends up to be 0, I might use the whole quadratic formula, then again I might not. And then if it turned out to be negative, I'll stop using the quadratic formula because that would be silly. All right, so let's try it. Let's put b, always in parentheses, minus 4 times a times c. And so my discriminant is going to equal 25 minus 24, which is 1. This is going to cross the x-axis twice because I got a positive. So now I'm actually going to go and use the quadratic formula. I'm going to do the negative of b. b is a negative, so the negative of b is a positive. Plus or minus the square root of the discriminant. I'm not going to rewrite it all. I'm just going to put the 1 in there. And that's going to be over 2 times a. I'm going to simplify that and get 5 plus or minus 1 over 2. So I've got two problems here. I have x equals 5 plus 1 over 2, which is 3. And then I also have x equals 5 minus 1 over 2, which I believe will be 2. So these are the zeros of the function. We're going to have 3, 0. We're going to have 2, 0. What does it mean to be zeros? They're x-intercepts. They are going to cross the x-axis at those two places, 3, 0 and 2, 0. All right, now I need my vertex. And remember, the formula for the vertex is hidden in the quadratic formula, just like the formula for the discriminant is hidden in there. B squared minus 4ac all over 2a. All right. So there's my discriminant. By default, by process of elimination, the x-coordinate of the vertex must be found by doing negative b over 2a. So let me do that. X is going to equal negative of b, so it's going to be positive 5 over 2, so it's going to be at 2.5. All right. Now, Rebecca, you just found something very important. See the x equals 2.5? That's your axis of symmetry. Yeah. Go to where x is 2.5 and put a vertical line going through there. Yeah, the parabola will be symmetrical about this point right here, about this line right here, excuse me. All right, so let me make that a skinny little line. A skinny little boy from Medina, Ohio. Actually, I'm from Parma Heights, but I'm not very skinny anymore, but that's okay. All right, there we go. So there's my axis of symmetry. Its equation is x equals 2.5. The parabola will be symmetrical about it. Notice the two zeros are exactly the same distance from it. That'll be true of all the points except the vertex. The vertex will sit on the axis of symmetry. All right, so now I want to find the vertex. So I'm going to go to y equals 2.5 squared, what was it, minus 5 times 2.5, and that'll be plus 6. By the way, this one was factorable. I just picked it because it would be really easy to work with. So 2.5 squared, it would be 6.25, I believe. 125, so it'll be 1250. It's negative plus 6. Look at these like terms here. I really have the problem of 12.25 minus $12.50. That must mean that the y-coordinate is a negative quarter. So the vertex is going to occur at 2.5, negative 1/4. And there we go. So my vertex is going to be right about there. And then I can draw my parabola. Oops. I didn't like that was going too wide there. Okay, that's pretty good there. All right, so there it is. All right, let's do another one where the discriminant will not come out to be a positive. Let's see what happens here. So first of all, we're going to go A, B, C. Easy as -1, 3, -5. Go for my discriminant. B squared minus 4, A, C. And I'll get 9 minus 20, which will equal -11. So I'm not going to use the quadratic formula on this one because it's not going to do me any good. This parabola will not cross the x-axis. There will be no x-intercept, and therefore the quadratic formula won't tell me. It'll give me a non-real root, a non-real answer. All right, so now I am going to go find the vertex. So I'm going to find the vertex, and I'll get that by doing x equals the negative of b over 2a. And so that'll be -3 over 2 times -1. So that'll be 1.5. Right, 3 over 2. That's the x-coordinate. That's also the axis of symmetry. X equals 1.5. So, you know what, I might start organizing my work here. And I'm going to put 1.5 in for x. And then I'm going to get a value for y out, and that'll be my vertex. So let me get my graphing calculator up here. Oh, grapher. I feel like Mickey Mouse. Oh, toodles. All right, let's see here. So I'm going to have 1.5. Oh, I need a negative out front there, don't I? So a negative of 1.5 squared plus 3 times 1.5. What is it, -5, I think? Yeah, it is -5. -5. And so this would be the y-coordinate of the vertex, which looks like it's about -2 75/100. So let me get that in the table. All right, so -2 3/4. All right, now I need 2 other values. I love to put 0 in whenever I can. And since 0 is 1.5 units to the left, I'm going to go 1.5 units to the right, and I'm going to put 3 in. All right, so when I put 0 in for x, I get y equals 0 plus 0 minus 5, which is -5. So that's going to be a -5 here. And then, because of symmetry, this will also be -5. You can do the math, plug 3 in, but you're going to get -5 out, I guarantee it. All right, so 1.5, -2 3/4. 1, 2, 3, maybe right about there. 0 is at -5, and 3 is at -5 as well. All right, and so my parabola will do this. Okay, my vertex is this point. My axis of symmetry is x equals 1.5. All right, that's it for the video. Rebecca, I hope that helps you out. Mr. Lawrence signing off. Have a good night, everybody.